Okay, so now we're in the same spot here that we were in. Let's see if I can find one. That we were in last week when we were doing problems like this, right? The difference is we're here we were evaluating for as x approaches a value, but I couldn't plug that value in here and here because that would give me 0 over 0. So the situation that we're in now is similar to that. Where are we? Here we are. The situation we're in now is similar to that. The difference is I can't plug in a 0 for h, because if I put a 0 here and here, I get 0 over 0. So we can simplify this. So let's do that. Now, the simplifying of this isn't going to look like it did before, at least not right away. Okay? Simplifying this, we don't have any radicals, so we don't have to worry about conjugates right now. We don't have any, squared binomials, we don't have any difference of squares that we want to factor down. The simplifying of this, and in a lot of the problems that we're going to do, the simplifying is we expand and then we simplify. So we're going to take this, the limit as h approaches 0, and we're going to expand the x plus h squared. So we square the x, we square the h, we multiply the x and h and double it. That's our shortcut for squaring a binomial. You'll notice here I put parentheses when I plugged in the x squared. If you thought that was kind of weird, you'd be justified in thinking that. But we're plugging in a function that's going to be subtracted. And when there's more than one term in that function, those parentheses are going to be really important. Right now they're not that important because we're just subtracting one term. But if that function, if f of x up here has more than one term, we're definitely going to want those parentheses around it. So I'm just doing that just to get into that habit, model that for you so that you get into that habit. Okay? So now I'm subtracting that x squared, and then we have an h on the bottom. So from here, how does this shake out? How does this simplify? What happens? The x squareds are going to cancel, and we have this. Okay, now, is this simpler? Yes. Is it the most simplified it can be? No. And the problem still exists that if I try to put this 0 here, here, and here, I still get 0 over 0. That's a problem, right? So how do I fix it? Anybody? You'll be on my YouTube channel forever if you can answer this question. How do I fix that problem? Factor out h. There you go. Forever. You'll live in infamy. Not infamy. Infamy is a bad word, right? You'll live forever on the YouTube page. You'll be able to say, kids, this is me, and then play the video, because YouTube's going to exist forever, probably, right? What do you guys think? Forever? Sorry. Good. All right. Good. Thank you for keeping me on track. We're being recorded, right? So if we factor the h away from the two terms in the top, we factor the h away from 2xh, that leaves us with 2x. We factor the h away from h squared, that leaves us with an h. And by factoring the h out of every term in the numerator, I can cancel it with the one h that's in the denominator. So now these will cancel. And the problem has been, or the issue that we were having, no longer exists. The h that was in the denominator is gone. So I don't have to worry about getting 0 over 0. And I can evaluate the limit as h approaches 0 by plugging the 0 in here. And we get 2x. Now, okay, now I'm going to stop this.